Hello, younglings. How are you today? Today, I was hoping to teach you a little bit about one of the fundamental things that happen in the universe. Some science, that is vibrations. Do you know anything about vibrations? Have you ever seen a vibration? Have you ever heard a vibration? Well, you're going to. I'm going to show you vibrations, teach you about them, and you will hear them. So first, I have this tool. This is called a tuning fork because it looks like a fork. I don't think it would be very effective to eat with.
No.
But we are going to show you some things. This particular tuning fork vibrates at 512 hertz. That is a unit of frequency, or what pitch the sound is. Let's listen. Do you hear that? It's vibrating. Can you see it vibrating?
No.
No, neither can I. But we can make it vibrate. And because of the way it is built, it will always vibrate at 512 hertz. But we can make it vibrate at different amplitudes. We can make it vibrate loudly, at a high amplitude, or soft at a lower amplitude. I want you to take a look at my water here. Let's see if we can see the vibrations. Did you see it? Did you see it? That was a vibration at 512 hertz. Let's do it again. Vibration is energy moving through matter. When I hit my tuning fork, I make it vibrate. Those vibrations, move through the water and vibrate it too. There are other things that make different kinds of vibrations. For example,
Can we have a cat break?
I have found this Muggle instrument. It's called a guitar. You may never have seen it before. But this Muggle instrument has some strings on it. And these strings are of different sizes and tautnesses. Some are very massive, they're bigger, and some are less massive. They're smaller. Some are very, very tight. Some are not so tight. The stiffness and the mass of different materials make a difference in how they will vibrate. For example, if we look at this first string, it is the thickest. And when I use my Harry Potter guitar pick to pluck the thickest, most massive of the strings, it makes a low pitch. That's a low frequency. If I pluck the thinnest string, that's a high pitch. Different. Masses, size of strings makes things go from low pitch to high pitch. And together, I hear that there are some Muggles that can make music. I'm not one of them. So, there's something else we can do. We can change the size of this, the tautness of it. Let's look at this first string. It's a very low pitch, a low frequency. But if I make it shorter, it becomes higher. And shorter yet, higher. And even shorter, very high pitched.
And also very hard to play.
And also very hard to play. So the size, the stiffness.
What happens if you make the smallest one shorter?
Let's make the smallest one shorter. gets higher and higher in pitch. And it doesn't vibrate very well.
Makes
Now,
it hard to play.
different frequencies, different pitches vibrate at different speeds. In other words, this lowest pitch, its wave is low and slow. The energy moves in a low and slow manner. The highest pitch, the energy moves in a very quick way. How big it moves is the amplitude. Now, I'm going to suggest that at home you can find a box. Any kind of box will do.
Makeup box.
I found this pink box.
It's my makeup box.
I made a makeup box. And then if you can find rubber bands of different mass and stiffness.
So basically different sizes.
Yes.
Because not everyone knows what those words mean.
Well, that's what we're learning today. Mass and stiffness affect the frequency. So I'm going to take this rubber band and put it over my box.
Can I plug it? And it won't work if you have it set on the table. You have to hold it while
So
playing
that the
it.
vibrations can resonate in the box. Would you pluck? Listen,
Mom, you
listen. They're different frequencies. You can make a musical instrument at home by changing the mass and stiffness. You can change the stiffness of the rubber band by changing how big the box is that you put it on. The bigger the box and the longer stretch the rubber band is, the higher pitched it will be.
She can't make music, I can.
I can't make music.
Mom,
Now.
I'll cross buns. Bum, 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 bum. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Just 1, 2, 3 on the last one. Yeah.
I believe that was 3 blind mice.
It was supposed to be hot cross buns.
Hot cross buns. What is hot cross buns? One, two, three. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. We've just learned a song. Basic vibrations. We have music. Excellent. Now, everything has vibrations to it. Everything that has movement vibrates. And all of those movements make sound.
Sound is vibration.
Sound is vibration. So when I pluck my strings, I make energy, and that makes vibrations. And the energy transfers from one molecule to the other until it gets to your ears, and you can hear. Did you know that even your ears make sound when you listen to something?
Whoa!
When you go to the doctor, they may put a little microphone in your ear and play special sounds. And they can use that tiny microphone and listen to the sounds that your ear makes while it listens to things. And that's how they can tell how good your hearing is, to see if those parts of your ear actually work the way they should. All right. Those are some basic bits of information about vibration and sound. We are going to use vibration and sound. This is my familiar, my cat. We are going to use vibration and sound to teach you some magic. It will befuddle the muggles. All right, come back and we'll learn.